and was a visiting academic of University of Southampton, United Kingdom. Her current research is focused on machine learning, hardware acceleration of photomic, gene regulatory networks, and cloud classification using field programmable gateway arrays. Dr. S.M. Vidaranachi, I invite you to lead the session.
Thank you, Kavinder. Good afternoon, everyone, and welcome to the session 2B, Bioinformatics and Natural Language Processing session. And each presenter will have a time slot of 5 minutes, right? And for post presentation and 2 minutes for questions. So let's begin the session. Our first post presenter is SPBM Senadira from UCSC. I think he is absent today, so we can run his presentation video. And so I hand over the session to the main compare to run the video. Actually, I forgot the title, right? His title is Protein-Protein Interaction Network, comparison between pediatric neuroblastoma cancers and glioblastoma multiform cancers with gene expression data. Kavinder, is there any problem?
There seems to be an issue, so
Running the presentation.
Let me contact the person who's playing the videos.
Yeah.
Karthika. My supervisor is Dr. A.R. Veersingh. Bhagyasena. My supervisor is Dr. A.R. Veersingh. Our research topic is protein-protein interaction networks, comparison between pediatric neuroblastoma cancer and glioblastoma multiforme cancer with gene expression data. Overview of our presentation starts from introduction, problem statements, objectives, methodology, results and discussion and conclusion. Protein works together. Protein-protein interaction networks explains how these proteins interact with each other in order to perform a cell task. So, analyzing protein interaction networks will help to see the inside of cancer and how the cancer grows in body. Objectives of our presentation is to compare two main cancer types by using protein interaction networks. Sub-objectives are to develop protein-protein interactomes based on gene expression data and to compare and contrast those networks to find highly connected gene clusters which has biological meaning. The methodology we have used as follows. We have downloaded NBL and GPM gene expression data from CSBio portal and we purify the data and normalize them. We extract genes from the human interactome which has the all gene protein interactions for human, and we have extracted the NBL and GBM highly varied genes and their first neighbors from the human interactome. Then we have used several algorithms such as MCODE, cluster 1 and MCLIV for identify highly connected communities in the protein-protein interactions that we have developed. Then we have compare and contrast those networks. These are the data that we have used for the analysis. We have used the genes and donors, and then we have filtered based on their highly varied genes. Then we have generated 6 main protein-protein networks from human interactome by using the highly varied genes and their first neighbors. Then we have run several algorithms, community detection algorithms, on top of these networks and generate these results. Following are the visualization of some of the gene networks that we have identified. MCODE algorithm identified highly dense regions. The cluster 1 is searching for overlapping regions, and the MCLIV is able to find complete graphs in the interactome. The conclusions of our results are there are highly protein network similarity between GBM and NBL cancers. There are no unique protein-protein networks for GBM or NBL. There are 4,148 protein networks identified to common to GBM and NBL. MCODE and cluster 1 are able to find biological important regions from the protein interactomes. MCLIV can find complete protein graphs from the interactome. Hierarchical algorithmic FAG and MCL algorithm are unable to produce any results. Thank you.
Okay, thank you. As the author is absent, we have to skip the question session. I think it's better to move on to the next poster. The author is Mr. S.D.L.H. Mahishanaka. and he received the BSc degree in Computer Science from University of Colombo School of Computing in 2020, and currently works as a software engineer at Digital Mobility Solutions Lanka Private Limited. His current research interests include bioinformatics and dimensionality reduction techniques. His title is Supervised Techniques for Meta-Analysis of Cancer Genome Data. Now, I hand over the session to Mr. Mahishankar.
Sir, Sadhar. Sir, brother. Hi, I'm Lochana, and the video is playing from your side now.
Hi all, I'm Lochana Hasit Maheshanaka from University of Colombo School of Computing. My research topic is unsupervised techniques for meta-analysis in cancer genomic data. My supervisor is Mrs. Rupika Vijay Singh, my co-supervisor is Dr. Ruanveera Singh, and the advisor is Ms. Amali Pereira. Let's move on to the introduction. Cancer is a group of diseases which shows an abnormal growth of cells which have the potential to spread to the other parts of the body as well. Cancer cells are not responding to cell division or the signaling system of the human body. Therefore, cancers can't be treated through basic principles of medicine. If we get two patients with sick, and if we give the same medicine to the both patients, most of the time, both of them get cured. But if we give the same treatment to two patients with the same cancer, one might get cured and the other might die due to that treatment. Because of that, personalized medicine helps in better treatment for cancer patients. Therefore, the identification of cancer subtypes is important to make personalized medicine. Moving to the motivation. The cancer subtype identification task was done in past with lack of data and lack of computational power. Because of that, the identified subtypes can be ambiguous. But now we have enough genomic data and high computational power. Therefore, in present, high number of genes can be analyzed at once. When you consider the number of genes and the number of samples, the number of samples are less when compared to the number of genes. This is called the high dimensionality in genomic data. This high dimensionality makes cancer subtype identification task difficult. The existing methods for dimensional reductions sometimes doesn't suit for the cancer subtype identification task. The objectives of this research are explore the available dimensional reduction techniques for extracting significant patterns, develop a pipeline which will help in cancer subtype identification, and validating the result. In this research, we have used gene expression data, and we have used endometrial cancer data as a case study. Here's the research design. First, the data gathering part. We have used the endometrial cancer expression dataset in the TCGA pan-cancer study, which is available in the CBio portal. Then we have removed the missing values. The second step is the dimensional reduction. There are two main categories in dimensional reduction. Those are feature selection methods and feature extraction methods. From the literature, we have identified that the variance is the best feature selection methods for datasets which have a high number of features. From the feature extraction methods, we have considered PCA, TSNE, PCA after TSNE, and deep learning methods such as deep autoencoders. We assume that using prior biological knowledge is better than using completely unsupervised techniques. As a dimensional reduction method, we have used a model proposed by R. Chen and L. Yang, where the weights are trained with the existing classes. We used 4 pre-identified subtypes of the endometrial cancer from clinical studies. As a third step, clustering is done in order to identify the subtypes. We use Silhouette's method and the elbow method to decide the number of clusters. Then we have chosen the clustering algorithms. From the literature, we identify k-means shows better performance when applied to biological data. For validation, we have used internal and external validations. As internal validations, we have used Silhouette index and Dun index. For pseudo external validations, we have used NMI score and Jacquard coefficient. Are the experiments and results? First, we considered about the variance. We applied k-means with the highly varied 80% of the genes. We have taken 2 and 18 as the cluster size from elbow method, but we couldn't see any separated clusters. We did for the highly varied 60% of the genes for k equals 2 and k equals 5 from the elbow method. This also didn't give any separated clusters. Then we applied feature extraction methods. Here you can see the results after applying PCA, TC, PCA after TSNE. Since the third method has given better results for datasets like MNIST, it didn't work with our biological dataset. Then we tried the deep learning method with prior biological integration. From that, we could see 6 clusters there. To get the number, we have used Silhouette method. As you can see, for k equals 6, we have the maximum Silhouette width. Even though the highly varied method doesn't give good clusters in the feature selection methods, there was some impact on reducing the dimensional. Therefore, we use highly varied genes with this deep learning method also, and this gives 6 clusters and it gave more accurate results when we consider the internal validations. Let's go to the evaluation. From internal validations, we can see the highly varied genes with the deep learning based prior biological knowledge integration method have shown better values. For pseudo external validations, we have chosen cluster size as 4 since we had pre-identified 4 classes identified from the clinical studies. But here any specific pattern couldn't be seen from those. We assume that the reason is the actual number of clusters is different from 4. Moving to the discussion and conclusion, we have explored both feature selection and feature extraction methods for dimensional reduction. And from that, we have identified the deep learning method with prior biological knowledge integration improves subtype identification task. And since there's no ground truth available, the internal validations were used to discover subtypes. We have identified the deep learning method with highly varied genes forms a better dimensional reduction methods, and we can say the existence of 6 clusters instead of the 4 from the validations, and this new knowledge contributes to the scientific knowledge on endometrial cancer. Thank you.
Okay. Thank you, Maheshanaka. And are there any questions from the audience? Are there any questions?
I have one question. Can you hear me?
Yeah.
Although you may not be able to find a single file of ground truth, you may be able to find some cancer types from research papers. Did you compare them with your results?
From the dimensional, from a deep learning or some type of a method for endometrial cancer, I didn't see such a research. We had 4 subtypes from clinical studies. I identified a research from 2002 when I was doing the research.
Oh, I see. So you have compared them?
Yeah.
Okay.
Okay. I have a simple question as well. What is the type of deep learning method you use here?
This is a supervised, unsupervised mixed method. We first feed the input genes to the representational space, and at the last layer we compare with classes, and just before the last layer in the representation space, we are using that part to get the clusters with the reduced dimensionality, with reduced features.
Okay, thank you. Okay, let's move on to the next presentation. The author is Ms. Isanka Sandamini Rajapaksha. She is a final year undergraduate student in the Computer Science and Engineering Department from the University of Ruhuna. She has completed her internship with the WSO2 IAM team. The study she will present at ICTer 2020 is an outcome of her contribution to the Sigma Law legal information extraction, a project by the Data Search Research Center of the University of Moratuwa. Her title is Rule-Based Approach for Party-Based Sentiment Analysis in Legal Opinion Text. Now I hand over the session to Ms. Isanka.
Hello everyone, I'm Sanka Rajapaksha and our research is about rule-based approach for party-based sentiment analysis in legal opinion text. Let me give a brief explanation of our research problem. When lawyers and legal officers receive a new case, they have to go through all relevant court cases to manually find out some important information like arguments, counter-arguments, facts, evidences, advantages and disadvantages arguments in court cases with respect to each legal party. So this manual process consumes a lot of time and effort. Therefore, as a solution, we introduce an approach for automating this time-consuming manual process. Let's move on to the base concept of this research. Aspect-based sentiment analysis. It's a text analysis technique that separates text into aspects and then assigns each aspect a sentiment level like positive, negative, or neutral. Applying aspect-based sentiment analysis to the legal domain, we have come up with the party-based sentiment analysis that can predict the sentiment levels of sentence in a court case with respect to each legal party. To the best of our knowledge, aspect-based sentiment analysis not being introduced to the legal domain yet. Let's take an example sentence from a court case to make this clear more. In 2008, federal officials received a tip from a confidential informant that Lee had sold the informant ecstasy and marijuana. In this sentence, there are two parties, federal officials and Lee. If we take the sentiment with respect to federal officials, it has a positive sentiment. And with respect to the Lee, it provides a negative sentiment. In our approach is primarily built around the phrase-level sentiment annotator, which is specifically developed for the legal domain. In phrase-level sentiment annotator, the sentiment of a phrase is classified into one of negative or non-negative classes without considering any specific party involved in the sentence. In order to their approach, the sentiment classes of our approach are also negative and non-negative. Along with the annotator, the Stanford NLP tools are used to analyze the grammatical relationship of words in a sentence. In our methodology, first we find all expressions that refer to the same party in the sentence using co-reference resolution, then divide the sentence into sub-sentences using constituency parser, and extract the noun and verb phrases of each sub-sentence. Using phrase-level sentiment annotator, we take the contextual sentiment score and sentiment level of each verb phrase and apply different rules to take the sentiment of sentence considering each party mentioned. In the evaluation, we used a dataset which consists of 2,000 human annotated legal sentences taken from previous court cases to carry out our experiment and evaluations. In the experiment, we compare the sentiment class of each party picked by human judges and the proposed rule-based method which makes use of the sentiment annotator. We consider four classes as negative for the petitioner, non-negative for the petitioner, negative for the defendant, and non-negative for the defendant. And the results have been evaluated considering the standard measures of precision, recall, and F1 score. Finally, as a conclusion, we can say that our research introduced a novel approach to perform party-based sentiment analysis in legal opinion text. And overall, this illustrates how rule-based approaches can be effectively developed and applied to sentiment analysis at aspect level. As the future work, we can further enhance the accuracy of the proposed benchmarks by combining rule-based approaches together with deep learning techniques. Thank you all.
Okay, thank you, Sanka. Any questions from the audience? Okay, Isanka, did you use any tool for this phrase level annotation? It is not manual, right?
Yes, madam. I have used the phrase level annotator, which is it's a transfer learning annotator, which is specifically developed for the legal domain. So this our domain is also legal domain. So we have used that annotator for our study.
Okay, thank you. So we'll be moving to the last presentation. The author is Mr. H.M.M. Caldera. He received an MSc degree in Computer Science and Engineering from University of Morato in 2017. He currently works as a research assistant at the Department of Computer Science and Engineering in the University of Morato. His current research interests include predictive analytics, data science, artificial intelligence, social media data analytics, and neural networks. The title is Time Series Based Trend Analysis for Hate Speech in Twitter During COVID-19 Pandemic. Now I hand over the session to Mr. Caldera. Mr. Caldera, are you there? It seems some problem in the connection. Hello, can you hear me?
Yes, madam, we can hear you.
So what about Caldera's presentation? Is he presenting live or there's a recorded video?
There is an recorded video, madam, so let me check with the organizers.
Okay. Okay.
Hello everyone. Time series based trend analysis for hate speech on Twitter during COVID-19 pandemic. The research what we have done in last few months. Let's start with introduction. COVID-19 is an epidemic that spreads all over the world. Twitter is one of most popular microblogging platform. Moreover, it provides an open-ended discussions to anyone in the world. The study is mainly focused on the hate speech discussions in Twitter platform during the COVID-19 epidemic period. The main objective of this research project is identification of short-term trends. Most specifically, we would like to state the short-term trend in Twitter platform which related to hate speech. And we have scoped down the hate speech discussions during the pandemic period. Finally, we have an object to propose a novel forecasting model that can predict the commenting behavior using time series analysis. Obviously, in Sri Lanka, we do not have a proper identified hate speech trend line. We have no clue whether that is upwards or downwards. That means there is a problem that we have to solve to find out where the trend line is upwards or where the trend line is downwards. We have some previous experiences as Sri Lankans because there was a situation to completely ban the social media platforms in Sri Lanka. We have collected data from Twitter API during April 1st to May 15th, 2020. Then the collected tweets was classified by human to make identify whether those are hate speech or not. Once identified, it's in Sinhala language and it's hate speech. Then we have conducted a time series analysis to identify the trending behavior in hate speech discussions. Since this project is mainly focused on time series analysis, we have started with the timestamps extraction and we have to identify specifically is there any seasonality trend or a noise is available in the data set. Initially, we have done a boundary value analysis to identify what are the boundaries. After the analysis, we have revealed that maximum duration is 7 days and mean duration is 84.96 hours. Augmented Dickey-Fuller test conducted to identify the stationarity with a sample size of 25. Finally, we have identified there is no any seasonality throughout the commenting behavior during this COVID-19 period. An hourly based post analysis conducted to identify the trend line. As a technique, we have used moving average analysis. Finally, the results displays a downward trend line in the head discussions. The hourly analysis conducted using profit framework. It provides a well suit for time sensitive projects. Authors identified a logistics forecasting model to forecast as this for this project. As a conclusion of this project, we can state there's no any seasonality or cyclic nature in hate speech posts in the Twitter platform. Further, noise is common throughout the discussions and outliers are detected in majority of the cases. Further, very high velocity of interactors was identified in the initial half and the latter part it was very low. The interaction was proportionally decreases and the trend line is in downwards throughout the research project. Finally, I would like to say thank you all of you for the engaging with me for this presentation.
Thank you, Mr. Caldera. Any questions from the audience? We are already behind the schedule. Any questions? And I have a question. Did you use any pre-processing technique for this time series data processing?
Actually, madam, initially the null values was removed because there was lot of outliers in some situations. So outliers was removed to get the data extraction, data pre-processing.
Okay, only that processing.
Yes, ma'am.
Okay. So thank you everyone for attending the session 2B. We have to come to the end of this session 2B. So I hand over the session to the main compare.
Thank you, Dr. S.M. Vidanaramachi, and all the authors who presented. So now we can move on to the next item in the agenda. So we have two parallel sessions, 3A on bioinformatics and session 3B on applications of IT. But before that, you will have a tea break. So let's meet at 3:50